Okay, this is the second video in a three-part series, starting with net force. Now this one is about equilibrium. Equilibrium is the condition that you have whenever the net force is zero. So I'm just going to give you a couple of examples and a couple of synonyms. In this example here, you have a couple of people pushing on the same object. This one pushes with a force of 10 newtons to the right. This one pushes with a force of 10 newtons to the left. Since their forces are along the same line and they are equal in strength and opposite in their effects, then they basically neutralize each other. You have a net force of zero. In other words, you could add these two using vectors to make this one positive and this one negative, or vice versa if you like. Anyway, when you add them up, counting them as vectors, they add up to a net force of zero. By definition, that means that in this case, the forces on this box are in equilibrium. In the second example down at the bottom, you have a person pulling with a force of 10 newtons to the left and another person pulling with a force of 7 newtons to the right. These two forces are along the same line, but they are not equal in strength, and they are going opposite directions, so you count one of them as negative and the other one as positive. And when you add them up, you get a net force of 3 newtons to the left in this case, which usually that will be negative. So this is not equilibrium because the net force is not zero. So whenever you have multiple forces on an object, and I've only shown you two forces at a time, but whenever you have multiple forces on an object, you only have two choices. Either the forces are in equilibrium, and that's another way of saying the net force is zero. Another way of saying that is the forces are balanced, or the forces are going to produce not equilibrium. In that case, the net force is not zero, and the forces are considered unbalanced. So this would be unbalanced, this would be balanced forces, these would be unbalanced forces. So that's equilibrium. It's pretty simple.